Okay, guys, so we're going to go over this question two, which is the one that's quite tricky, and I think maybe a few people were unsure of how to get to the right answer. Just to show you, you can check question one by going into the library and going to the solutions, okay? So I've been able to place into the OneNote for you the solutions now, so that you can check your work as you go and check your work is okay. Obviously, we've got our formula n2 over n1 equals sine theta 1 over sine theta 2. Okay, so question one is fairly straightforward. You are given the substance and the refractive index, and you're just being asked to find the missing angle. So I'm not going to do a video for those. These answers are in the solutions, which you can be checking in OneNote. I'm going to go over this question, no question two. It's a difficult one, problem solving, and requires you to remember a little bit of maths when you're solving this. So, important information, we are given the refractive index, and we're also told that the light is entering a 60-degree prism. What that basically means is that this triangle is made up of three angles all equal to 60. That's all that means. So I think maybe people got confused with that bit at the start. If the refractive index of the prism is 1.48, calculate the angles x, y, and z. So first thing we're going to do is calculate the angle x. Now our formula n2 over n1 equals sine theta 1 over sine theta 2. We know the refractive index of the material is 1.48. Refractive index of air is 1. We've got our incident angle here, which is 50, the angle between the incident ray and the normal. And we know that we're trying to find our angle x. So, next thing we want to do is try and simplify our equation. So 1.4 over 1 just becomes 1.48. That's equal to sine 50 over sine theta 2. A little bit of rearranging, we can say that sine of this angle here is equal to sine 50 over 1.48. Now, obviously, we can inverse sine here. It kind of makes things a bit easier. So to find the angle x that gives us sine theta 2, we're going to do the inverse sine of sine 50 over 1.48. Sorry about that. And that comes out to be equal to 31.2 degrees. So x equals 31.2 degrees. If this is confusing, okay, if this line of working here into here, you're going to need to maybe go to your maths notes and have a look at your trigonometry rules again. I'll show you this one time over on the right hand side, just for anybody that's not sure. So if you have sine theta 2 equals sine 50 over 1.48, that tells us that sine theta 2, sorry about that, is equal to, you take your calculator, 0.51. Therefore, to get the angle, we're going to have to do sine inverse of 0.51, which gives us our answer of 31.2 degrees. So you can skip this working by going to this step here, inverse sine of sine 50 over 1.48. So back to the triangle. We now know that this angle in here is 31.2 degrees. Now, if we look at our triangle, it's quite clear we've got a few straight lines. Okay, so this is 90 because it's drawn perpendicular, the normal, to the boundary. That is 31.2. So what we can do is we can find out this angle in here by saying 180, take away 90, take away 31.2, and that gives us our next angle, 58.8. degrees. So this angle in here, 58.8. Now we've got another triangle we've just created. We've got this triangle with one corner of 58.8, one corner of 60. The next thing we need to do is find this angle in here. So all of the angles in a triangle add up to 180. So 180 take away 60, take away our 58.8 will give us our next value, which we're looking to put in to this corner of 61.2. So not actually using any formulas, just using our knowledge from maths that angles in a triangle add up to 180 to allow us to find the angles there. A little bit more to go. If this y line with the normal is a straight line, this is 90 degrees, we can find out the angle y through 180, subtract 61.2, subtract 90, which tells us that y is 28.8 degrees. So we can go back to the green pen, 28.8. In fact, we'll see if we can zoom in to make that a bit neater. Okay, so we now know that y is 28.8 degrees. So we're going to now try and calculate our angle Z. The first thing we need to do is write down our formula. We have got N2 over N1 equals sine theta 1 over sine theta 2. Now our substance in this case, the material which the light is going into is air. It is coming from the glass. Our incident angle is the angle in the glass, and our angle we're interested in is the angle in the air. So we now have sine theta 2 on the bottom of our formula. So we can simplify the left hand side if you wish. Those of you who want to just skip forward and do the inverse sine of the whole thing, you can. If you're not confident with that, then you can take your time, go through all the steps. To find sine theta 2. As usual, running out of space here. So now what we've got is sine of our theta 2 is equal to sine 28.8 over 0.67. And to find our angle, we can inverse sine that whole bracket. And that comes out in your calculator to be, let me just double check, 45 degrees in here. So quite a bit of working. You have to use the formula twice, and you have to remember the angles in a triangle add up to 180, and also you can add in right angles and look for straight lines to simplify. This recording will be on the Firefly blog for you to watch over as many times as you wish, and these solutions are in your OneNote. So if you go to the question booklet up here, you can just go to the page and you'll find the written solutions. And we will go on to look at some more questions and also how to do 3B, C, D and 4B and C later on in this period. So there'll be another video for you to follow after this one shortly.